Hey everyone, today we're going to be working through what I've called Chapter 1 highlights. Chapter 1 highlights is really based on a lot of the algebraic knowledge that you should be bringing into this course. In fact, a lot of what you see in Chapter 1 and Chapter 2 should be review for you. Now, we will go through the content pretty quickly for Chapter 1, but feel free to slow it down if you need to, rewatch sections if you don't catch something, and reach out to me anytime that you have questions. So to start with, I want to talk about the distance and midpoint of a line. Both of these are based on formulas, and if we're looking for the distance and midpoint, we're talking about a segment of a line or a piece of a line. Now, distance is actually based on the Pythagorean theorem, so it's based on a triangle. And if we're looking for the distance between point number 1 and point number 2, we're actually looking for the length of the hypotenuse of the right triangle that makes. So the distance formula is the distance between point 1 and point 2 is equal to the square root of the x length side squared plus the y length side squared, and we add those together inside that square root. So if we want to determine the distance between the points 3, -2 and -1, -4, we're just going to plug that into that formula. So here, if we put this as point 1, that means these points are x1, y1. And if we put that as point 2, we have x2, y2. Really doesn't matter which one is point 1 and which one is point 2 as long as you're consistent between them. So if I'm looking for the distance, that means the distance is equal to the square root of x2, which is -1, minus x1, which is 3, squared, plus y2, which is 4, minus -2, also squared. Simplifying, inside that first square root, I have -4. And the second square root, 4 minus -2, gives me 6. Also squaring that. And we have 16 and 36. Gives me the square root of 52. 52 does reduce into 4 times 13, so it reduces into 2 square root of 13 for our distance. Now, this is an exact distance, so anything you get by calculation like this is considered exact. If I were to put that into my calculator, I could get an approximation, but the exact value is always better. Midpoint is also based on a formula. So when you're talking about midpoint, we're really just talking about the average between 2 points. So it is calculated very much like an average. You do have a formula for it, but if you're looking for a midpoint, you're actually looking for a point in the middle where the x values are the average of the x points and the y values are the average of the y points. So remember, when you take an average of two numbers, you add them up, divide by 2. So that's what we're doing here with both of these. Same thing with this is going to be x1, or point number 1, point number 2. So if I want to determine the midpoint of the line segment and I have a graph here, we're going to graph them. So 3, -4 is the first point. So here's our point 3, -4. Second point, -2, 3. And we're finding the midpoint of this line segment. If I'm looking for the midpoint, we use a capital M. In a little while, we'll get to the small m, which we usually reserve for slope. So capital M is going to be an xy point. And it's equal to x1 plus x2, so 3 plus -2 divided by 2, so we have an average, and then the average of our y points as well. So y1 is -4, y2 is 3, taking the average, we get 1/2 for our x, and for our y, -1/2. Now, if I look at my graph, the point 1/2, -1/2 is right about here. So the representation is not too bad there. All right, moving forward, we can also find intercepts of a graph. Now, when we're talking about intercepts, we're talking about places where we cross an axis. So here I have an intercept. At this point here, we intercept the y-axis. At this point here, we intercept the x-axis. And at this point here, we also intercept the x-axis. So if I were to put some numbers on that, this is a scale of 0 to 2 here. So that's probably the point 0 in the x direction, 1 in the y direction. Looking forward, this would be 1 and 0. And this other one is not, it's not 2, not 2.5. I would say 2.25 in the x direction and 0 in the y. So there are intercepts based on a graph. So when you're looking at a graph, it's really just visual. When you're finding intercepts from an equation, what we're going to be doing is plugging in zeros for the opposite variable. So when we go to find intercepts from an equation, we plug 0 for the opposite variable. That means if I'm looking for the x-intercept, I let y equal 0, and then I solve for x. If I'm looking for the y-intercept, I let x equal 0, and then I solve the equation for y. So I'm always letting that opposite variable be 0. So if I want to find the intercepts of this equation and then graph it, first I need the x-intercepts. Really, the order doesn't matter, but I'm doing them first. So x-intercepts, we let y be 0. So x is equal to 3y squared minus 5y plus 2. So if I let y be 0, the first and second terms here go to 0 because we're multiplying by 0. So we end up with x is equal to 2. X is equal to 2 gives us a point where x is 2 and y is 0. So here is an intercept point. Looking for y-intercepts, that's when we let x be 0. So 0 is equal to 3y squared minus 5y plus 2. Now normally we see a quadratic or a polynomial of degree 2 with x's, but really it can be with any variable. So here I'm going to use it as y's, and if I'm going to try and solve this, we need to factor it. So 0 is equal to factors. I have a 3 in front of my y squared, so I know that I have to have 3y and y because those are the only things that multiply to 3. I need a 2 at the end, so the only things that multiply together to give me 2 are 1 and 2. I need them to equal 5 in the middle, so they're both going to be negative, and so minus 2 here, minus 1. So 3y minus 2 times y minus 1, just checking that, gives me 3y squared minus 3y minus 5y total and plus 2, so we're good. Now, anytime we factor, then we set each factor equal to 0 to solve. So 3y minus 2 is equal to 0, and y minus 1 is equal to 0. Adding 1 to both sides gives us y equals 1 here. 3y is equal to 2. Y is equal to 2/3. So I have two intercepts, 0 and 2/3, and 0 and 1. So 0 and 1 is here, 0 and 2/3. It's a little bit off graphically. Now if I want to plot a point or two extra, remember that a parabola or a quadratic equation looks like a parabola. So this one's in the y direction, and we'll talk about more about that next week. But when we're looking at this type of equation, I can plug in a point for y and then solve for x. So far I have a little curve right here that looks something like this. But if I want to see where y is going to end up a little higher, let's say we plug in 2 for y. So if y is equal to 2, then we can potentially get an x value where that occurs. So x is equal to 3 times 2 squared minus 5 times 2 plus 2. This gives me 12 minus 10 gives me 2 plus 2, or a total of 4. So we have a point on the graph at 4, 2, and then we can use that to plot. So it's going to be over here. Basic graph here is going to look something like this. Another thing that I wanted to review from chapter 1 is symmetry. So symmetry are reflections that are in a graph. We do have some technical definitions too. So there are 3 different types of symmetry that you may see. The first one is symmetry with respect to the x-axis. So if you have a graph that's symmetric with respect to x, that means that whenever a point xy is on the graph, the point x negative y is also on the graph. So symmetry with respect to an axis, if you think about it as folding the graph on that axis, the points of the graph would meet. So if I'm looking at this, if we fold it along this x-axis, both the top piece and the bottom piece would then match together, so it means it's symmetric. As far as the technical definition of xy and x negative y, that means that if the point 2, 2 is on the graph, then the point 2, negative 2 is also on the graph. That's what tells us we have symmetry here. So this is an example of something that's symmetric with respect to the x-axis. Similarly, we have some symmetry with respect to the y-axis. So remember that this is your y-axis here, and symmetry with respect to that axis means that if I fold it on that axis, my graph will match up from each side. Now, that also means that if your point xy is on the graph, negative xy also has to be on the graph. So our point 3, 2, I'd be looking for the point negative 3, 2 to also be on the graph. So we're changing the x value here. So looking at this, remember you can fold it and you get the symmetry. Now, if we're talking about the final type of symmetry, symmetry with respect to the origin means that we're pivoting based on the origin, the 0, 0 point. Now, in that one, if xy is on the graph, then the negative of both has to be on the graph as well. So if you're talking about 2, negative 2, for example, flipping the signs of both of those gives you negative 2 and 2. So those are the reflections that we expect to see. Now, if we're trying to determine if we have something that's symmetric with respect to the origin, it's not like folding based on something, but you can determine a graph is symmetric with respect to the origin if you turn it 180 degrees and the graph looks approximately the same. So here's an example of a graph. This is an example of the cubic function. And this graph has origin symmetry. Now, if I were to take this paper and then just flip it upside down 180 degrees, it looks the same. So something with origin symmetry, flip it over. If it looks the same, it has symmetry with respect to the origin. We can also test for symmetry using algebra. If we are testing for x-axis symmetry, we replace y by negative y and then we simplify. If we get an equivalent equation, then we have x-axis symmetry. This is like 0, so if you're testing for x, you do something to y. If we're looking for y-axis symmetry, we replace x by negative x and simplify. If we want origin symmetry, then we replace both. So we replace x by negative x and y by negative y and simplify. So for example, if I want to test this equation for symmetry, we'll go in order. So if I want to test it for x-axis symmetry, then what I'm going to do is I'm going to take the y and replace it with negative y. So negative y is equal to 3x divided by x squared plus 2. Now, when it says to simplify, what I want to do is I want to isolate y alone on one side like it was before. So if I can isolate it alone and then it still looks the same, then I have a symmetric equation. So to isolate that, I need to divide through or multiply by -1. So multiplying both sides by -1, I end up with y is equal to -3x over x squared plus 2. Be careful here. A common mistake is to put the negative sign on the top and bottom of the fraction. Effectively, that would cancel it out. So when you're distributing a negative sign over a fraction, you have to pick the top or the bottom, but not both. All right, so since this is not the same as this, it's the negative version, we do not have x-axis symmetry. Now, if I want to look at y-axis symmetry, then I'm going to replace my x variable with -x. So y is equal to 3 times -x divided by -x squared plus 2. Simplifying that, I get -3x over, since this is negative inside a square, I can reduce that negative out, plus 2. Now I still have a negative on this side where I didn't before, so our equation does not have y-axis symmetry. As far as origin symmetry, in origin we replace them both. So -y is equal to 3 times -x divided by -x squared plus 2. Now I've already simplified this side in the previous step, so -y is equal to -3x over x squared plus 2. Now if I divide through both sides by the negative or multiply by -1, here my negative cancels on the left hand side and I'm left with just y. On the right hand side my negatives cancel as well and I have 3x over x squared plus 2. So yes, this is symmetric with respect to the origin. Now, graphs don't have to have symmetry, so some graphs are not symmetric with respect to anything. You will see some that are with respect to each of these throughout the course this semester. Now, we'll deal a lot also with linear equations, so I wanted to review briefly some lines and slope. So let's say that I have a linear function or a linear equation, and the line looks something like this. So some reminders about what we actually see when we're looking at a line. Typically, when you see a line, it's in what's called its slope-intercept form. So it looks y is equal to some sort of slope plus some sort of intercept. Now looking at this, the slope is actually a measure of the rise of that line over the run. So that is a measure of the slope, rise over run. We'll go through how to calculate that in just a second. And that here is our slope. B is our y-intercept. So the point at which it crosses the y-axis. So if I'm looking for B here, this is the point 0B. Y is our equation of the line, so looking at that. Now, as far as the slope formula, if we want to calculate a slope, and we represent that with a small m, the slope of a non-vertical line is y2 minus y1 over x2 minus x1. We sometimes see this listed as delta y over delta x. And what those deltas mean are the change in. So we have the change in the height, delta y, over the change in the run, delta x. It's important to note that x1 cannot equal x2 here. If you have x1 equal to x2, you end up with 0 on the bottom. Cannot divide by 0. So this is a vertical line, and anytime you have a vertical line, the slope is undefined. We do have several formulas that have to do with lines. First one, point slope form of the line. So this is used when you have a point and you have the slope of the line. So it's y minus y1 is equal to m times x minus x1. And this is how you build that equation. Now, if you're looking at slope-intercept form, this one's probably more popular. This is your y is equal to mx plus b. We also have the equation of a vertical line. Vertical lines are lines. They're always in an x equals format, so x equals a. Horizontal lines are y equals lines. So if I'm trying to write a horizontal line, this is always going to be y is equal to something like b. If I need to find the equation of a line containing 2 points, it's really 2 steps. First, you have to find the slope, and then you can use one of the line equations to construct the line itself. So if I want to find the slope first, y2 minus y1 over x2 minus x1. So I'm going to label this as 0.2. This one is 0.1, so we have an x and a y coordinate for each of them. So y2 minus y1 gives me 5 minus negative 2. x2 minus x1, 3 minus negative 1. Simplifying, 5 minus negative 2 gives me 7. 3 minus negative 1 gives me 4. So I have a slope of 7/4 here. If I want to then find the equation of the line, I can use the point slope equation or the slope intercept equation. They're both valid. So using the point slope equation, then I have y minus y1, so y1 is negative 2, is equal to m was my slope that I've already calculated, so 7/4, x minus x1, so negative 1 here, and simplifying. Here this turns into y plus 2, and I have 7/4 x plus 1. I'm going to distribute and then I'm going to move the 2 over. So y plus 2 is equal to 7/4 x plus 7/4. Subtracting 2 to both sides to isolate my y, I get y is equal to 7/4 x, and 2 in fourths is 8. So 7/4 minus 8/4 gives me minus 1/4. So this is the equation of my line in slope-intercept form. So slope-intercept. And this is the most common form that we use. The reason that we use this form so much is because we can graph it easily. So we can plot the B point and then count the slope from there. Now the point slope form of the line, this is using point slope. Your homework may ask you for either form of the line, so just be conscious of what form you're being asked for when you're going through and doing homework. We'll also be dealing with some circles this semester. So a circle is a set of points all equal in distance from a central point. Typically, we denote the central point HK. The distance is called the radius. So if I have a center point HK, A circle is all the points that are the same distance away from that point. Now that's a really rough sketch, but this distance here represented would be the radius, or r. All those points make up the circle. Typically we see the equation of a circle in what's called standard equation, our standard form. And the standard form of a circle is x minus h plus y minus k squared is equal to r squared. So this is the standard equation of the circle. And if I want to find the standard equation of a circle with their center at the origin, that means that my hk are both equal to 0. So looking at that, that means I have x minus 0 squared plus y minus 0 squared is equal to r squared. Simplifying it simplifies to x squared plus y squared is equal to r squared. For those of you who have already taken trigonometry, the unit circle is a special case of the circle where r is equal to 1. So you have x squared plus y squared is equal to 1 in that case. Now if I want to find the standard equation of a circle with a radius 3 and a center at 5, negative 2, then the information that I'm given, r is equal to 3 and hk are 5, negative 2. So I can really plug that into our equation. So x minus the x value squared plus y minus the y value. It's negative, so it's really y plus 2 squared is equal to r squared. 3 squared gives me 9. So that would be the equation of that described circle. If I want to find the standard form of a circle with a center at 0, 5 and a solution point at negative 1, 3, it gets a little bit more complicated. So this 0, 5 is my hk. So if we look at what we have so far, what I have is that x minus 0 squared plus y minus 5 squared is equal to r squared. But I don't have r wasn't given to me. So if you're looking at what a circle actually is, remember that a circle is all points that are this radius distance away from that center. So if I need to find out what r is, what I need is the distance between that point 0, 5 and the point that's on the circle negative 1, 3. So remember the distance formula. We're going to subtract our x values and square it. So negative 1 minus 0 squared, and our y values and square them. And this is really what we're solving for, is the radius. So our first term simplifies to negative 1, squaring it gives me 1. Here we have 5 minus 3 gives us 2, squared is 4. So here our radius is equal to the square root of 5. Simplifying our equation, here I have x squared plus y minus 5 squared is equal to the square root of 5 squared. Or finally, x squared plus y minus 5 squared is equal to 5. And there's the equation of our circle. Graphing a circle means finding our center point and then our radius and plotting some points. So here we have the equation x plus 4 squared plus y minus 6 squared is equal to 4. Now if I want to graph that, then I need to find out what the center is. So our center hk, remember this is x minus h. So if I have a positive in here, that means my h is negative. So here I have negative 4, y minus k We already have a minus there, so we have 6. This value on the other side is r squared, so our radius here is equal to 2. Now plotting that, -4, 6 gives me a point right here. Radius equal to 2. I'm going to go out 2 units in every direction and plot a point. So 2 units to the right, 2 units down. Oop, that's 3. 2 units down, 2 units to the left, 2 units up. And then my goal with plotting this in is just to make it look as little like a square as possible. So there is my circle plotted based on that equation. All right. That is it for today. Please get started on your homework on my math lab. You will go through and practice some of these concepts, and then we will head back here and talk about section 2.1. Have a good day.